Okay, so welcome. This lecture is about functions in Python. So as I just mentioned, we have discussed almost everything in this lecture before, but in a different lecture, which was titled Pseudocode and functions. And so it will be the same material, but this with the focus on the Python. But even when we were talking about pseudocode, I think I showed you Python then. So I think this won't be too much trouble. Yes, that's perfect. That's what you should be able to read. So let's get started. In the bottom of this slide, the blue rectangular box is a process, we would say, in a flowchart. But this is a special process. The fact that it has two little parallel lines on the sides, that means that it is a function or a subroutine. So a subroutine or a function is represented in a flowchart like that. Now this, when it has been nicely labeled, it shows us the way that we're going to represent our functions in Python. And so what we have is we have a variable z, which takes the value or is assigned a value, which is output or which is returned from a function, which is called function. You'd never call a function, right? You know, the word function would be replaced by some word that you had made up, which describes what that function does. So it wouldn't be called function. Then X and Y would be what we call parameters or arguments. They're going to be the inputs that come as global variables into the function. And then inside the function, they will act as, they will be replaced by a local variable. So the function has an input, which are the arguments. In this case, there's two of them. And it has an output, which is the return value. And Z is going to take that value in this case. So there's a flowchart. That's representation of it. Now, this slide has nothing to do with a flowchart. This slide now is all just pure Python. Now, in pseudocode, we don't, when we create a function in pseudocode, we have another slide on that a bit later here, but we use a function word. In Python, we use DEF. DEF is a reserved word in Python, and we use that followed by the name of a function that we want to create. So when we want to create a function, we say DEF, we give it its name, then we add brackets, and inside the brackets, we'll put the names of any arguments, parameters that we want to input into that function, and then we finish the line, which is the header of the function, with a colon. And so that should be familiar to you, the idea of using the colon. We use that with all of our control structures in Python, and we certainly use it when we're creating a function. So we use the colon. Then everything after the colon should be indented by at least one indent space. That will all be part of the function, everything that's indented after the colon. There mentions their parameters. One thing that I haven't mentioned is a return statement. At the end of the function, you will do a return, which will mean you end the function. Now, with the return statement, you can add the name of a variable or some number or whatever, in which case that will be output from the function. The function can output a value. And so we use this word call. It's not like a telephone call. When we're talking about call with a function, what it means is at some point, we want to execute that function and make it do something. We do that by calling the function. And so a call in a program will be stating the function name and passing any parameters into it. That's what we call a function call. So a function call obviously doesn't, I was going to say it doesn't happen inside the function. It can, in which case that's what we call, we have a special name for that, where it's working inside itself. I'm sorry, I'll come back with the name on that in a minute. But normally we call the function from another function. Okay, we call a function from another function. And as it says, they're only executed when they're called. So the slide that I'm showing you now is a slide that you have seen before, I think, because I think I remember seeing this slide when we were talking about functions and pseudocode. There's a black box there, And I think the black box, the blackness of the box is not a coincidence. I think that's there for a reason. And so the blackness could be referring to the fact that we have this idea of a black box. And I'll tell you what I mean by a black box. Black box just means that we have something, we know what goes into it, and we know what comes out of it, but we don't know what happens inside. We just know that this goes into it and that comes out of it. And we can measure what goes in and what's out. We would call that concept a black box concept. Now, in the context of this little bit of code here, this is a black box. We know what goes into it. Assignment, quiz, and test go into it. We know what comes out of it, overall grade, but we don't know what happens. It doesn't say what happens. All right, so that's our function. That would be the function call. We call a function there, and we don't know how it works. Well, somewhere else, I mean, computers are not magic. They actually have to be told, we have to tell them what to do. And how we tell them what to do is we explain the function. So here, somewhere else, this would be where we define the function. Here we're explaining what the function does and how it does it, and then its return value. Yes, Abdullah, I can tell you want me to ask me a question. They didn't set up the assignment quiz test to 0? Yeah, because there's no loop. Because there's no loop, I guess I didn't have to initialize it to 0. Now, what you're looking at now, is pseudocode. So again, we're not talking about Python now. We've moved on back to pseudocode. And that's why we have this word here, function. If this was going to be translated from pseudocode into Python, we would remove the word function and replace them with DEF, right? DEF is what we do for when we're creating a function. So in pseudocode, when we're saying that we want to create a function, we use the word function. And that's useful because in some other programming languages, like JavaScript, you might do that, all right? But in Python, we don't use function, we use DEF. What else is different? Okay, so in pseudocode, here we're indicating what type of variable each of these is. You don't have to do that in Python. Python will be able to tell by the value that you put there what type of data it is. And the other thing that's different would be the curly braces. We use curly braces in pseudocode. We use curly braces in many programming languages like C and Java and JavaScript, but we don't use it in Python. In Python, instead of doing the curly braces, we use a colon and we use indenting. So Python in some ways is a little less typing. I won't say it's necessarily easier, but it's a little bit less typing. Now, the other thing that we've got here is we've got a main function, which we've called overall grade. And yeah, it kind of works the same way. Now, looking at this is the pseudocode. The next slide, very next slide I'm going to show you is this pseudocode translated into Python programming. So this is what it would look at. Now, there's 2 steps in any function. In making a function work in Python, there's 2 steps required. The first step is you define or describe the function, right? So here we have that, and we start with our reserved word DEF, which means what's going to follow is going to be a new function. So we're going to create a function called average grade. The X, Y, and Z are going to be the parameters. And so they will act, X, Y, and Z will act as local variables within the function. So that means that the only place that you're ever going to be able to print X, Y, and Z is if you try and do it from within the function. If you are out here in the main, you won't be able to print them because they only exist inside the function. All right, now we did talk about that previously when we spoke about the memory stack. Remember I mentioned that? It's not actually part of the course, but I thought it was useful as a way of describing what's happening here. So as I said, there's 2 things that you have to do to make the function work. First, you have to declare the function, which is give some code, which gives the instructions of how that function is going to work. And then somewhere you have to call the function. What I'm putting my cursor over at the moment, that is a function call. At this point, the function will be executed. Now, when I say at this point, what I mean is after these bits of code have been done and before this bit of code. that's when we call the function. This has nothing to do with it. This is just explaining what will happen when we call a function. But the program is actually going to start right here where my cursor is. That's the start of the program. This here is just explaining what's going to happen when we call this function. Yes?
So something confused me in the second test. Same idea. When we do print stuff, we're supposed to do plus str.
They both work the same way, right? So by just putting a comma here, then we rely on the print function to understand what our variable is and to print it. Okay. I guess it's a more secure way of doing it is to put the plus and the str, because that will convert it to a string for sure, and you'll get your print. But both will work. Sometimes if you put too many of these together in one statement, you might get an error with it. And so the str, I think, for me, I think it's a better way of doing it, but it's more typing. And so some people wouldn't want to do it. If you only have one variable like this works fine. Okay. So we're continuing the idea of functions. There are different types of functions. The previous few slides and few minutes of me talking to you was about functions that are built by the programmer. This is where you have an idea of something that you want to do as a function. You write the function yourself, you do the DEF, and then you do the call. With built-in functions, we don't have to write the function. The function's already been written and it's been given to us with our distribution of the program. All we have to do is call the function. So this is where it's different than those ones we've been talking about. In these functions, you just call the function. So what do we got? It's good to know these functions. These functions you've used. The int function, the parameter, what you pass, the input to that is going to be a string or a float, some other data type, and the returned value, what will be returned by the int function, will be an integer number. And of course, it'll only work if the value that you put into it can be converted to an integer number. I mean, if you try and pass your name in and convert it to an integer, well, that won't work. All right. But any number that you've for whatever reason you have it as a string, this will convert it to an integer. str does the opposite. It takes whatever value you have, and it could be a float, it could be a integer, and it will convert it to a string. And so str, we were just talking about that. That's very useful in our print statements. Float will take whatever value that you have, and it could be an integer, as long as it's capable of being changed, right? It could be an integer or a string, and it'll convert it to a float value. So float value is going to have a decimal component. You're going to have a part of the number could be decimal. The len, what here is, so again, you pass in a string to the len function, and what it returns is an integer value, which is how many characters in that string, how many spaces in that string, how many places in that string, not spaces, because space is a character, right? The input function, you pass to it a string, and the string is a prompt, which is asking the user to do something. This is where str works a lot better than the comma, because this requires a print. Then it outputs another string, which is a string which captures whatever it is that they typed. And so if they typed a number, it's going to come as a string. That's why we were using the int function with it, because we're inputting from the user a string, but we wanted a number. And so that's why you saw in many of our little programs, we'd try and get a number from the user, and we'd say int brackets input, because the input returns a string. The print doesn't return anything. All print does is you pass a string to it, and it puts the string up on the screen for you. All right, so it's not actually returning a value. So we got some others. So those are those. ABS stands for absolute value. You put in a number, and it could be a negative or a positive number. The absolute value will always be positive. So if you take a -2, it'll change it to a +2. Power, P-O-W, what that's going to do is it's going to take X and raise it to the power of Y. So whatever two numbers you put there. Ascii, now, I don't know how much time I wanted to spend on ASCII. Do Google it, I suppose. We could spend some time on it if you want, but I don't think it's necessary. There's this thing called the Ascii Code, and it works with all the operating systems that we work with. And basically, the Ascii Code has 255 characters, and the characters relate to the numbers from 0 to 255. And so, for example, each one of these numbers relates to a particular character that you can type from your keyboard, or a character that could end up in your document. And so, for example, if you take the number 65, that translates in our ASCII code to the capital A, and then 66. So they're in order. 66 is going to be B, right? Then there's a lot of other things, like, so you have a different number for a carriage return. You have a different, every symbol that you can think of that you can type has got a number, right? One of these numbers, 0 through 255. You get to the number 97, and that's a little a, and then 98 is a little b, etc. So I guess one thing that tells us is that as far as the computer is concerned, a capital A is not the same as a little a. They have a different ASCII code. And that's important because we know that, when we type things, we like to separate upper and lower cases. And there are many applications that we use where the case is important. So that's how ASCII works. ASCII, you put in a number. So for example, if you did this, if you said ASCII and you put in the letter A, the return value that it would give you would be number 65. Okay, so that's how that works. Now CHR works the opposite way. So this would give us 65. CHR, if you took the number 97 and did a CHR on it, that will return the value little a. Does that make sense? Because the ASCII code for little a is 97. So I mean, this is kind of useful because you could use it. Supposing you were writing a thing where you wanted to do passwords or something like that, or you wanted to have some special code, you're playing with your friends. Oh, let's make a special code up. We can make codes. One of the things that people do with making sort of special codes is they'll do a shift, right? So they'll say, okay, every time you see an A, we'll change it to a B. It's easy. With this, it's easy. All you have to do is add 1 to the ASCII code, right? Get the ASCII number, convert, add 1 to it, A becomes a B, and B becomes a C, etc. It's very easy to sort of play around with numbers and letters and characters using the ASCII code. I hope these other ones make a bit of sense to you. If you pass in an integer value to the bin function, what it will pass out is a binary number, the binary number for that integer number. Likewise with the hex, you pass in it requires an integer number. If you pass in an integer number for the hex, it'll pass out a hexadecimal number. Okay, so that's how those work. In the lab that you'll do this week, and like next lesson that we have, I don't know if that's tomorrow, or we'll be using some of these functions. So that's why I spent a little bit of time talking about them. Those are built in. Now, so when we get to this point here, now we're talking about our third different type of function. Our first different type of function was the function we write it ourselves. User written function, DEF. Here's my name of my function. Here's a parameter. This is what I want to happen in this function. Then later I'll call it. The second one, I just finished talking about. The second type of function, what we did is that those are built in and distributed with your version of Python. And so all you have to do is, oh, I know what function I want. I want to use the int function. These are functions that you're just going to use all the time, and so they're there. The third type we're now going to talk about, which is functions that are in libraries, but they haven't been distributed to you, right? They're not in the memory when you start up your Python. So if you want to use them, you have to first import them. You have to do this thing called an import. With a library, you have to import. It's very easy to import. You need to have the library on your computer. Now, if you've downloaded idle from the website, which is the python.org website, that will have the math library, and some other libraries will be there. But you still have to import them, all right? And so at the start of your code, when you want to use any of these special math functions, you'll have to import the math library then you can use the functions. Now, the thing about the library functions is when you use them, instead of just, so this is our normal one, right? That's an inbuilt function. And, with the math one, the difference is you have to say like this, a square root, right? Or pi. First, you have to import the math. Then when you call the function, you have to do it like that. You have to actually say. Now, usually with functions, you have to have it. I don't know if you need that for pi. Let's see. We've got an example of it here. No, you don't need it for pi. So this is the example of using that. We want to use the pi function from our math library. And so because it's a library, we have to import the math library, and then we can call the function. And so we're actually calling two math functions here. We got the square root function, which does have brackets. And so you have to pass a parameter into it. So I guess you could say the pi function doesn't have any parameters and it doesn't require you to use the brackets, which is unusual for a function. All right, so one of these is an error. I found out when I tried to do the coding on this. No, maybe not. Yeah, no, it's right. It was my error. These are all right. We've used these functions. These are functions which, well, they're special kind of functions. So I guess this is the fourth type of function. So we had one where we write our own, two where it's built in, three where it comes with a library, and now we've got these. These ones are string method. We call them a method. Method is a word that we use with object-oriented programming. So if we're talking about methods, we must be in a object-oriented programming language. So like Java and Python. Python is an object-oriented language. And so what is our object? Whenever you create a string is supported in the Python programming language as an object. A string is an object. And so as an object, objects can have methods which describe or do things with the object. So what can you do with strings? Well, these are some of the things you can do with strings. You can convert them to uppercase. You can convert them to lowercase. You can convert them to capitalized case. Now, in every one of these ones where we're using a method, there's a dot. The thing before the dot is a variable name for the string. Here's some others. Now, the ones above there, these ones are doing a conversion. Now, these ones in red are slightly different than the ones above. The ones above actually do a conversion on the string. The ones below, they are Boolean. And so the Boolean methods, what they do is they just return a value of a true or a false, depending on the status of the string. So if the string is all uppercase, then whatever the string name dot is upper will return true. Likewise, so is it uppercase? Is it lowercase? Is it numeric? Is it alpha, which means is it made up of alphabet letters, or is it all numeric? Which includes, alphanumeric, which includes alphabets and digits. I'm sorry, I know people are a bit tired. I won't make this last too much longer. But I will ask you after the lecture I'll post on D2L some stuff about what we're gonna do next time, so you can have a look at it. The print function doesn't have any return value, but it does have some arguments that you can use. And I've shown you this end one before. And there's another one, which is the new line. What the new line will do is within a single print statement, you can have multiple lines. And so every time you want a new line, you just put the /n, and what will be printed on the screen will be on another line. The end works kind of in the opposite direction. Instead of having a new line, you can replace the new line with some other character. And so that's what's showing here. We have two print statements, but they print all on the same line. So how do we do that? At the end of the print, we would normally get a new line, but we replace the end there with a comma and end. We say, okay, instead of having a new line, we're just going to have a space. And so it just puts one after the other. And I think, yeah, we got one more slide after this, two more, three, oh, four more slides. So I'm not going to. All right, let's just do this as quick as I can. I just see people are so tired. So two-step process. We define the function. That's what's happening here. Now, this function uses, within it, it uses a math function. We don't have to define the math function. That's in the library, right? But we have to import the library. Here we're defining our function, and here we're calling it two steps. First, we define it, then we call it. Now, why did we have to do the radius? The program starts here, by the way. The program starts at line 5. It doesn't start at line 1. Well, I mean, at least 2, 3, and 4. We don't do 2, 3, and 4 until we get to line 6. And I'm going to show you that in an example in a couple of slides. And so here's another one. Here we're defining the function, and this function has a couple of parameters and returns a value. Here is where we are calling the function. We call that function more than once. So we called that function where first we created a variable and we pass a variable to it. Here we're doing it without creating a variable. All we're doing is using a number, an integer, because that works on integers. And so the last one, we're going to finish it here because, as I said, you guys, I know you're tired. And this one, I think, does the most things. It's got a while statement in it, and it's got the function. I promise you, we'll make this the end of the lesson. I know you're all tired. I can see that. So let's look at it, see if we can concentrate on this last one. The two-step process. First, here, where my cursor is now, we're defining our function. So we define our function, we give it a name, we tell it that it has to have one parameter. Okay, so within that function, because we've imported the math, within that function, we're going to do a calculation which involves that value which has been passed in is raised to the power of 2, which is the same as squaring it. And then we return that. This is our output. Our output will be the result of that calculation. S and A are local variables. They're only available inside the function. So if I try to print in this print statement here I'm printing the area. If I tried to print S or A, they would not print. They're not available. Now I could print area here if it was created yet. What else is there? I could print side here because they're global variables. See, they are created in the main. So our global variables, they're available anywhere. But our local variable only available within the function which it was created. I hope that makes sense to you. That was, by the way, something we must have talked about before because it did come up in the test. All right, so what I'm going to do is I'm going to take this. And as I said, I can see you're tired, so I'm going to try and make this as quickly as possible. We're going to copy that code. We're going to put it into a Python code. There's Python there. And so what does this do actually? This is lecture 15. The final thing that we do in lecture 15. So we're importing some math. What I'm going to do is I'm going to put some line numbers here so you can see what happens. You can see the sequence. So line 1, line 2, line 3, line 4, bear with me. Line 5, 6. Okay, now this one, because I copied from, was it Word? It was PowerPoint, right? Sometimes the quotes are the wrong kind of quote. You see, the only quote that Python really is going to work with is this straight up and down quote. This one here, it doesn't work with that well. So I'm going to change it for the straight, and you just see the color change because now it recognizes it as what it is. Now you'll see that the color is different here for line 7. And that's because I'm inside a string doing that. Whereas this is just a comment, red in Python, red is comments and green is strings. And so most of these I'm just commenting. So that's line 8. There's line 9. Oh, sorry. And here's line 10. So the reason why I want to do that is I want to print at line 4. I'm going to, so we're at line 4. And what I'm going to print there is, well, what? The value of A. I think maybe the value of A and the value of maybe I'll also print the value of S. Those are the two things that are there. Oops. So we do A and S. There's nothing on the other end of that, just a bracket. Okay, so let's try and run this and see what will happen. What I want to show you is the what I want to show you is the order in which things happen. So it asks you for the, now look, the first thing that's happening, the first thing that we see printed is line 7. Can you guess what's going to be the next thing? If I type in a number here, I'm going to just type in any number. So the side of the square, it's going to make a square. It's going to be 7 times 7. It's going to be 49. But what's the next number that's going to be printed? You know, it goes in order, right? We started here, so we're going to go here. So what's going to happen? It's going to print line 8. 10. Well, let's see. It went to line 4. Then it went to line 10. So how did it go to line 4? Because this is a function call. Here we're calling the function. Sorry, here we're calling the function and we're setting the value to area. Then we're going to print the area later. But can you see that, right? We went 7, 4, 10. What am I going to do when I put in another number? I'm going to do this how many times, by the way? I'm going to do this 5 times, right? So count starts out as 0. We're going to keep going for 5 times. So what's the next thing after line 7? Yes, every time it's going to go 7, 4, 10, 7, 4, 10, 7, 4, 10, right? Until it does that 5 times, and then it will stop. 7, 4, 10, 7, 4, 10, 7, 4, 10, 7, 4, 10. Right, here we are. Here's our program. 7, 4, 10. 7, 4, 10. Right, now why is it going to 4? Because this is the call. I hope that makes sense to you. I've said it many times in this lesson, but that's what I want you to get. There's 2 parts to making. This is our user-defined function. First, we describe the function or define the function, DEF the function, and then we call the function. The program starts here, right? This is the main. This is where this program process starts. It doesn't start here. All that happens here is this actually goes into memory so that the computer knows what to do when it gets to this thing here. Well, what do I do with area square? Oh, that's right. That's what I do with area square. It has an input. Well, the input here is a side. Side's global variable. When it gets here, it becomes a local variable, and we're able to print it there. If I try and print S here, I'm going to get an error. All right, I spoke about that a lot. I think that that might be enough. You guys okay with that? If you want, we can look at the tutorial, but I kind of saw people going to sleep. So what I'll do is I think I'll leave it at that. Unless you have any questions. All right, thanks for coming, students. Appreciate it. And I think I've recorded this. And so I'm going to put the recording up on D2L. Thanks, Nehala.